Welcome to Brain Vision.
Now we are given, for the first part of this question, a photon and an electron having the same energy, 20 eV. We want to find what is the wavelength. So for the photon, energy can be written as hc over lambda. So its wavelength is just hc over the energy, where hc can use 1240 eV dot nanometers, and the energy is 20 eV. So we should get about 62 nanometers for the wavelength of the photon. Now for the electron, on the other hand, this energy is related to its kinetic energy, right? This equals to its momentum, right? Momentum squared over 2m, p squared over 2m, and we gotta use this to find what is our de Broglie's wavelength, given as h over p, which will be equals to h over square root of 2m times the kinetic energy. To convert the 20 eV into joules for this by multiplying by 1.6 times 10 power minus 90. Right, and we should get a wavelength of about 2.74 times 10 power minus 10 meters, or just 0.274 nanometers. For the next part of this question, we are given both of them have the same wavelength, right? Both the photon and the electron have wavelength of 250 nanometers. We want to find what are their various energies. So for the photon, it's very simple. Energy is equals to hc over lambda. Right, again we use h times c to be 1240 eV dot nanometers. Then divide that by 250, we should get 4.96 electron volts. For the electron, the wavelength signifies to us what is the momentum. Is about 2.65 times 10 to the power minus 27. From this we can calculate the energy, which is just p squared over 2m. This should give us about 3.856 times 10 to the power minus 24 joules. But in order to compare it with our photon, we have to convert this into electron volts. So we divide this by 1.6 times 10 power minus 19 to give us the energy in terms of electron volts. Should be about 2.41 times 10 power minus 5 electron volts. Well, given that we want to probe some organic molecule and we don't want to damage it, right? The molecule is given to be about 250 nanometers. So the wavelength that we should use should be also around 250 nanometers. Now, to determine which particle will damage the molecule the least, it depends on the energy, right? So less energy will be better because you are causing less probability of ionization occurring in the organic molecule, which would damage the molecule, right? So the lower the energy, the better. And you can see that for the same wavelength, our electron actually contains less energy, right? Our electron is much less energy compared to the photon for the 250 nanometer wavelength, and therefore the electron will actually be a better choice, right? That will less likely damage our molecule.